Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2023, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1, here is a list of numbers. We've got 8, 11, 19, 26, 39, 49, 65 and 114. From this list, write down an even number. Okay, even number just has to be a number ending in 0, 2, 4, 6 or 8. I've got 2 to choose from. Could have the 8 or the 26. I think I'm going to go for the 8. A square number. So the square numbers are 1, 4, 9, 16, 25, 36, 49. So 49 is a square number, isn't it? So I'm going to pick that one, 49. And a factor of 57. Okay, well, what are the factors of 57? Well, it's going to have to be an odd number. Numbers that divide into 57. Well, 1 and 57 does, but I don't have those. What else? Does 3 go into 57? I think it does. 3 and 19, doesn't it? So that's going to be my factor of 57 then, 19, because 19 times 3 is 57. So 19. Question 2, Kai has 4 differently numbered cards. The range of the numbers is 14. The median of the numbers is 9. All the numbers are prime numbers. The lowest number is 5. Work out the numbers on the cards. Write the numbers in order of size. Okay, so I've got the lowest on the left, which is 5. I've got 4 numbers altogether, so I've got 3 more to find. Now, I'm going to use the first fact straight away. The range of the numbers is 14. Now, if 5 is the lowest, then the highest is going to have to be 14 more than 5, and isn't it? It's going to be 19. So I've got 2 now, 19. Now, the next fact says that the median of the numbers is 9. Now, the median at the moment is going to be halfway between my 2 numbers there, isn't it? So when I add them together and divide by 2, I'm going to get 9. So one of them has to be less than 9 and one has to be greater than 9. So what are the prime numbers that we haven't had yet? So we've got, well, we might have 5 again. Could have 7, could have, not 9, 11, could have 13. Okay, so it could be, well, actually, I think we've got 2 choices then. We could have 5 and 13, I guess, or we could have 7 and 11, can't we? I think I'm going to go for 7 and 11. 7, 11. Okay, so if you add 7 and 11 together, you get 18 divided by 2, you're going to get 9, so that works. All the numbers are prime. Yep, 5, 7, 11, 19. The lowest number is 5. I think that all works. Okay, like I say, I think you could have also had another 5 and 13 on here, because that also adds up to 18. So, yeah. 2 choices for those 2 middle ones. Doesn't really matter which one you went for. Question 3. Here are the first 4 terms of a sequence. I've got 5, 12, 19 and 26. Write down the next term in the sequence. Now, what sort of sequence is this? First thing I usually look for is the gap between them. So 5 to 12 is plus 7. 12 to 19, well, that's also plus 7. And 19 to 26 is also plus 7. So this is a linear sequence or arithmetic sequence. So the next term is going to be plus 7 more than 26 then, isn't it? If you add on 7 to 26, you're going to get 33. So that's going to be my next term, 33. Explain how you worked out your answer. Common difference is 7. So 26 plus 7 is equal to 33. Okay. Question 4. A fair 6-sided dice numbered 1 to 6 is rolled. The diagram shows a probability scale, and I've got like the A, B, C, D, E, F, and G numbered on it. Which arrow shows the probability that the dice lands on 5? Okay, well, the probability of getting a 5, well, I've got 6 faces on the dice altogether, of which one is a 5. So my probability is a 6th. Okay, so which one is a 6th? I think that's B, isn't it? Okay, so D is a half, and then I've got 2 divisions between those. So those are each going to be a 6th, aren't they? So I've got B is 1 6, 2 6, 3 6, or a half, 4 6, 5 6, and then 6 6 is 1. So yeah, I'm going to go for B. Lands on 7. Well, there isn't a 7 on the dice, so the probability of getting a 7 is 0, isn't it? There's no chance. It's impossible. So that is A, is impossible. Lands on a number greater than 2. So the probability of greater than 2, what numbers is that then? That could be a 3, it could be a 4, it could be a 5, it could be a 6. There are 4 different numbers that are greater than 2. Note that 2 is not greater than 2. So it's going to be 4 out of 6. Okay, so remember D or half is 3 out of 6. So E is going to be 4 out of 6 then, isn't it? So it's going to be E. Question 5a, write 0.17 as a fraction. Well, decimal numbers, the first digit after the decimal place is tenths, isn't it? And then the next one is hundredths. So to take a decimal and write it as a fraction, all we have to do is then take those 2 digits and write it over 100. Now 17 is prime, so we're not going to be able to find any numbers that divide into 17 and 100. They're going to cancel it down, so that's going to be my answer, 17 over 100. Okay. Part B says write 0.04 as a percentage. I just think about percentages as the first 2 digits after the decimal point normally. So I'm reading that as 4% then. So that is going to be 4%. And then write 7/8 as a decimal. I'm going to do this by division because I can't remember what 7/8 is off the top of my head. So I'm going to put 8 outside my bus shell and then 7 underneath. Now 8 doesn't go into 7, does it? But it has a remainder of 7 then, which I can then attach to the next digit along. So there wasn't a digit long, so I added a 0 in. So that makes 70. So then 8s into 70, well 8 8s are 64, aren't they? So it could go in 8 times, remainder 6. And then 8s into 60, well I know 7 8s are 56, so it goes in 7 times, remainder 4. So I'm going to have like 40 to go next. And then 8s into 40 go 5 times then, isn't it? So that's my answer then, 0.875. 0.875. Question 6, here is a function. The input goes into the function, it's multiplied by 4, and then 7 is added, and then we get the output. So find the input when the output is 87. Okay, so this one we're working backwards, aren't we? So they've given us the output, they're saying the output is 87. What must have been fed in to get 87? Okay, we're working backwards. Something plus 7 was 87. So the kind of the mid value is going to be 80 there, isn't it? Because 80 plus 7 is 87. And then something times 4 was 80. Well, what do I have to multiply by 4 to get 80? It's going to be 20 then, isn't it? So if 87 came out, then it must have been that 20 went in. So then when I times it by 4, I get 80. And when I add 7, I get 87. Now it says the input is x and the output is y. Write an equation for y in terms of x. Okay. Well, if I input x into my equation, and then the first thing that's going to happen to it is that it's going to be multiplied by 4. And if I multiply x by 4, I'm going to get 4x. Okay? Then, if I then add 7 to that, if I've got 4x and I add 7, then I'm going to get 4x plus 7. Now I'm told that that is the same thing as y. So y then must be equal to 4x plus 7 then. That's the equation version of this function. X goes in, it's multiplied by 4, get 4x, add 7, get 4x plus 7, and that's equal to y. Question 7a, work out 3 to the power of 5. I'm just going to tap that straight into my calculator. I'm going to press 3 and then the power button and then 5. What do I get? I get 243. 243. Okay. The cube root of 2,744. Same thing. I'm going to type in the cube button on my calculator and then the number 2744, and that comes out to 14. Easy marks. Find the value of y if 384 is equal to 6 times 4y. I think what I'm going to do first, I'm just going to divide both sides by 6. Okay, so then that will cancel and it will just leave me with 4y is equal to something. That might be helpful. So 384 divided by 6, that's equal to 64. Okay, so what I want to know then is 4 to the power of what is equal to 64? Well, I know 4 to the power of 2, 4 squared is 4 times 4, that's 16. And then times 4 would be 64 already then, isn't it? So then 4 to the power of 3 is what we're looking for here then. So y then must be the same thing as 3. So what is y? Y is 3. Finally, write 3 to the minus 1 as a fraction. Negative fractions just means 1 over the positive version of that power. So 3 to the minus 1 is just 1 over 3 to the 1, or just 1 over 3. Okay, so it's just a third. It's the reciprocal of your number. Question 8, 450 grams of flour costs £1.44. Work out the cost of 1 kilogram of flour. Okay, so I'm going to use what's called the unitary method for this. I'm going to set up as a ratio. So flour to cost, that is going to be 450 grams to £1.44. Now we want a kilogram, and a kilogram is 1,000 grams, isn't it? So I'm going to take my 450 and I need to bring it up to 1,000. Now the unitary method means go via 1. Now if it was a non-calculated paper, I might go via 50, it might be easier, but on the calculator it doesn't really make any difference. So I'm just going to go via 1. And I'm going to go via 1 by dividing by 450 to take me from 450 to 1, and then times in by 1,000 to go back up to 1,000. Okay? Now if I do that to the other side, I'm going to divide it by 450 as well, and then times it by 1,000. That's what I'm going to do on my calculator then. I'm going to type in 1.44, I'm going to divide it by 450, and then I'm going to times it by 1,000. What do I get? I get 3.2. So that is 3.2. Now that's going to be my answer, except that my answer is in pounds, so I can't really write 3.2 pounds. I'm going to have to write that down as £3.20, aren't they? They do steal a mark off you if you don't put that extra zero in sometimes, so yeah, make sure you write it in pounds and pence. Question 9. A farmer keeps sheep in a rectangular field measuring 120 metres by 180 metres. The farmer can keep up to 20 sheep per hectare in his field. 1 hectare is 10,000 square metres. Work out the maximum number of sheep that the farmer can keep in the field. Okay, so we've got a field and we know its dimensions. It is 120 on the short side and 180 on the long side. So then its area, how much space is in the field, is going to be length times width. It's going to be 120 times 180, and that comes out to be, calculate what's 120 times 180. Apparently it's 21,600. So that's 21,600 square meters. Now I know that 1 hectare is 10,000 square meters. So that in hectares is going to be, or divide it by 1,000. Divide by also by 10,000. Hectares, 10,000 square meters. That's 2.16. 2.16. Okay, so that's 2.16 hectares. Now, if you can do 20 sheep per hectare, so then sheep, the number of sheep is going to be the hectares, 2.16, times the number of sheep you can keep in a hectare, which is 20. So I need to times that by 20, times by 20. And I'm going to get 43.2. Okay, so he could keep 43.2 sheep in his field, but I don't think he'd want to keep 0.2 of a sheep, would he? It would be quite messy. So I think it's going to round down in this case, isn't it, to 43 sheep. Okay, so that's roughly 43. Okay. Question 10a. Finley is asked to solve the equation 5x plus 4 is equal to 90. Finley's working is shown below. 5x plus 4 is 19. So he's adding 4 to both sides and getting 5x is equal to 23, and then dividing through by 5 and getting x is equal to 4.6. Write down the error that Finley has made. Okay, well, he made his error here, didn't he, by adding 4 on. He should have subtracted it. I've got 5x plus 4 is equal to 19. So to resolve that, to make 5x, you're going to have to take 4 away from both sides and not add it. So it should be 5x plus 4 is equal to 19. Subtract 4 from both sides. I should be getting 5x is equal to 15. Okay, so what did he do? Finley added instead of subtracting 4. Okay, so Finley added instead of subtracting 4. You could either do it either way, really. I've probably done too much again here. You could either write the words or you could have done the maths. Both would have been acceptable answers. Right, part B, Charlie is asked to use the formula v equals u plus at to find the initial velocity when the acceleration is 5 and the final velocity is 29 and the time is 3. Okay, so we've got v, we've got u, we've got a, we've got t. So v is the final velocity and we're told that is equal to 29. That's 29 there. U is the initial velocity, and actually that is what we're trying to find. We're trying to find initial velocity, so that's the one we want. A is the acceleration, and the acceleration we're told is 5. Okay, and then finally t is the time in seconds, and that is equal to 3. That's equal to 3. Okay, so it's just a matter of then plugging those in the equation, isn't it? So can you see the error that Charlie has made then? Well, he has put in 29 as the value of u, when actually 29 is the value of v. Okay, so what has Charlie done? Charlie substituted v is equal to 29 as u is equal to 29. It should be 29 is equal to u plus 5 times 3. Okay, so it should have been substituted in here, and he substituted it in here, look, on the wrong side. Okay, question 11. Cookies are made using the ingredients. To make 24 cookies, you need 240 grams of butter, 360 grams of sugar, 2 eggs, 240 grams of flour, 170 grams of cranberries, and 100 grams of white chocolate. Okay, now we've got the ingredients for 24 cookies, and we want to know about 48 cookies. Okay, so the ratio of cookies to eggs is 24 to 2 in the main recipe. Look, so I've got 24 goes with 2. Now we want to know how many eggs go with 48 cookies, so we're going to have to double up our recipe here, aren't I? So if I times that by 2 and times that by 2, I'm going to get that I need 4 eggs. Okay, so how many eggs do I need for 48 cookies? I need 4. How much sugar do I need to make 6 cookies? Again, if I do cookies to sugar, that's 24 to 360 from the main recipe. Now if I want to change the recipe and make 6 cookies instead, I'm going to be dividing by 4, aren't I, to get from 24 down to 6. So 360 divided by 4 falls into 360 go 90 times, don't they? So I'm going to need 90 grams of sugar to make 6 cookies. Then it says Ashley has 520 grams of cranberries and plenty of the other ingredients. Ashley thinks this is enough to make 80 cookies. Is Ashley correct? Show working to support your answer. Okay, so we needed from cookies to cranberries. I've got 24 cookies requires 170 grams of cranberries. Now, is that enough to make 80 cookies? I want to go to 80. Now, again, I'm going to use the unitary method here, going via 1. So what I'm going to do is I'm going to take 24, divide it by 24 to find the amount of cranberries I need for 1 cookie, and then I'm going to scale it up to 80 to find the amount of cranberries I need for 80 cookies. Okay, so doing the same thing with the cranberries, dividing by 24 and times in by 80. I'm going to take 170 and I'm going to divide it by 24 and I'm going to times it by 80 then, and that comes out to be 566 2/3. 566. I'm just going to round it off to 566.7. Okay, so do I have enough cranberries if I've only got 520 grams? I don't have enough, do I? I need 566 2/3. So is Ashley correct? No. Why? Because 80 cookies requires 566 2/3 grams of cranberries and don't know if Ashley is a boy or a girl. I'm going to go for girl, and she only has 520 grams. Part D says Darcy makes 100 cookies. They are put into packets, each holding 6 cookies. Each packet of 6 cookies is sold for £1.35. Darcy sells all of these packets. Work out how much money Darcy receives. Okay. So how many packets are there? So the number of packets, that's going to be 100 divided by 6, isn't it? Now 100 doesn't divide by 6. I'm going to get a remainder. So if I divide 100 by 6, I'm going to get 16 2/3 again, aren't I? 16 2/3. 16 2/3. Which, you know, normally would round up because 2/3 is closer to 17, but I can't make a 17th packet out of the amount of cookies I've got. Okay, I've only got, well, I'll have 4 rather than 6, so I won't be able to make that last packet. So I'm going to actually have to round that down to 16 packets. Okay, has to be rounded down. Okay, and then if each packet is sold for £1.35, then the amount of money she's going to get is going to be the 16 packets multiplied by the £1.35 that she sells each of the packets for. So we need to work that out. 16 times £1.35, 16 times £1.35, that comes to 21.6. Now again, remember this is in pounds and pence, so my final answer needs to be £21.60. Okay, and then she can get to nom 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 the 4 final cookies herself. Question 12, work out the surface area of the cuboid. Okay, well, in order to work out the surface area, I'm just going to quickly draw the net of this shape. So you've probably seen this before. It looks a little bit like a cross. So I'm not going to draw mine super accurately, but hopefully you'll get the idea. Okay, So that's roughly the net of my cuboid. Okay, and then I need to put the dimensions on the net so it's about what it should be. Okay, so let's say that this face here, that's going to be this rectangle here, isn't it? Okay, and that is 6 by 4. So it's 6 in that direction and 4 in that direction. So its area is going to be 6 times 4. That's 24, isn't it? Okay. Now either side of it, going to have these faces here, there and there. Look. So they're going to be here and here. So one of the sides is 4 and the other side is 5. Look on the diagram. So that's going to be 5. So the area of this one is going to be 4 times 5, which is 20. And the same for this one. This is also going to be 4 times 5, which is also 20. Okay. Then I've got the front and the back face. So the back face is that face there, look. And it's also going to be this face here. So those two are going to be the front and the back face. And the front and the back face are 6 times 5, aren't they? 6 times 5, which is 30, and that one is 6 times 5, which is 30. Okay, and then finally you've got the lid on the top here. This is the lid. Okay, and the lid is the same as the bottom, isn't it? So it's going to be the same as that yellow one there. It's going to be 6 times 4, which is 24. Okay, so then the total surface area is going to be those all added together. So I've got 30 plus 24 plus 30 plus 24 plus 20 plus 20. Okay, so adding all those up, I might just add 3 of them together and then double it. That might be quicker. So 30 plus 24 plus 20, that comes to 74, and then times that by 2. I'm going to get 148. So that's 148 square centimeters. Question 13. Karim runs 2,460 meters in 8 minutes. Calculate his average speed in meters per minute. Okay, so I'm going to use the DST triangle here. Distance, speed, time. What's D? What's S? What's T? Let's have a think about that. Karim runs 2,460 meters. So that is distance, isn't it? That's the one that goes here. So distance is 2,464 meters in 8 minutes. So 8 minutes is the time. Okay, 8 mins. So then the speed is the one we're looking for. Okay, so cover up speed on our triangle, and it tells me that it's distance divided by time. So speed equals distance over time, which is 2,460 divided by 8. Okay, 2,460 divided by 8, that is 307.5. 307.5 meters per minute. Okay. Karim says this means I can run 6,150 meters in 20 minutes. Write down one assumption that Karim has made. Okay. So how has he come up with this then? So if he can do 2,460 in 8 minutes, 2,460 in 8 minutes, and he's saying, well, then in 20 minutes I can do 6,150. Okay, so presumably he's used some sort of ratio method here. So he divided by 8 and times by 20. We've done this a couple of times already today. So dividing by 8 and times him by 20. Is that what we get? Let's double check his work. So 2,460 divided by 8 times by 20. Yeah, that does come out to 6,150. Okay, but that's not what this question is asking us. It's actually asking us what our assumption is. Now his assumption is that he's going to carry on running at the same speed, isn't he? Okay, so what he's done here, he's used the same distance travelled in the same amount of time, so pretty much the same speed over a longer journey. Now I don't know about you, but once I start running quite far, I get tired and might slow down. So he has assumed that he can continue to run a longer distance at the same speed. So he's assuming he's going to keep going at the same speed, isn't he, and not slow down. Maybe I should say that, and not slow down. Okay, or speed up, I guess. Right, so yeah, he's assuming he's going to run at the same speed. Question 14, show the inequality x is greater than -2 on this number line. Okay, so how I do that is I draw a circle at -2, and then we have an arrow pointing off to the right, because it can actually be any number bigger than -2. So it could be any number along this direction here. Okay, so that's how we show it. So we have a circle at the number, the end point, or the limit, and then an arrow going off in the right direction. Now this is for x is strictly greater than -2. Now if it actually asked for greater than or equal to, I would have filled out that circle like that, because that would mean that the endpoint -2 is part of the range of possible values for x. But here, because it didn't say that, it said strictly greater than, I leave an open circle on the number line. Okay. Question 15, Finley has 72 sweets. Finley gives 25% of the sweets to Alex and 1/6 of the sweets to Umi. Show that Finley has 7/12 of the sweets left. Okay. So what is 25% of the sweets? Well, 25% is the same thing as a quarter. So I think I'm just going to do 72 divided by 4 then. So work out what that is. 72 divided by 4, that is 18. So he's giving 18 sweets to Alex. 1/6 of his sweets to Umi. So presumably it's the whole total here, isn't saying what's left over. So it's still going to be of 72. So 72 divided by 6, that's 12. Okay, so that means he's given away a total of 18 plus 12, which is 30. Okay, so if he's given away 30 sweets, sweets remaining, it's going to be the 72 sweets he started with minus the 30 sweets he's just given away. So that means he's got 42 sweets left. Okay, so what is that as a fraction? So as a fraction, that's going to be 42 over 72. He's got 42 72ths of the amount of sweets he had left over. Now, if you can't see how to cancel it down, you can just type it into your calculator. 42 divided by 72, it'll tell you that it's going to be 7/12 as required. Okay, or you could have just spotted they both divide by 6. So divide by 6, divide by 6, and that's going to take you down to 7/12. Okay, so we've shown that he's got 7/12 of his sweets left. Question 16, the diagram shows a quadrilateral and an equilateral triangle. The perimeter of the quadrilateral is equal to the perimeter of the equilateral triangle. Find an expression for the length of one side of the equilateral triangle. Give your answer in terms of x in its simplest form. Okay, so I'm going to work out the perimeter of the quadrilateral first. So to work out the perimeter, all I really need to do is add all the sides together. So it's going to be 5x plus 4 plus x plus 2 plus 9x minus 5 plus x plus 8, 6x plus 8. So I'm just going to add those 4 sides together. So 5x plus 4 plus x plus 2 plus 9x minus 5 plus 6x plus 8. Okay, so now all I need to do is collect like terms together. I've got lots of x's. I've got 5x, x, 9x, and 6x. What does that add up to? So that's 5, 6, 15, 21x. So I've got 21x, okay, and then how many numbers have I got? I've got 4, 2, minus 5, and 8. So 4, 2, and 8 add up to 14. Take away the 5, that's 9, isn't it? So it's going to be 21x plus 9. So that's the perimeter of the quadrilateral. So the length of one side of my equilateral triangle then is going to be a third of the perimeter of the equilateral triangle. And the equilateral triangle has the same perimeter as the quadrilateral. So one side of this is going to be 21x plus 9 divided by 3. Okay? Now, 21x and 9 have both got a factor of 3, so we could factorize that 3 out and make 3 lots of 7x plus 3 over 3. And then you'll see then that that 3 and that 3 cancel, and it just leaves me with 7x plus 3. So the length of one side is just 7x plus 3. Okay? 7x plus 3. Question 17. Multiply out and simplify 3x plus 7 times x plus 2y. Okay? Now, I know students like to just do 2 eyebrows, a nose and a mouth, or FOIL to multiply these out, but often students miss terms out when they multiply, and I always recommend actually do it on a grid. Okay, and then you know that you're not going to miss any of the terms out. So I do 3x and y, one of the brackets along the top, and x and 2y, one of the brackets down the side. And then I'm going to multiply them out, and this way I won't miss out any because I've got a space for each of the types of number I'm going to get. So 3x times x, that's 3x squared. X times y is xy. 2y times 3x, that's going to be 6xy. And 2y times y, that is 2y squared. So you see I've got 4 terms here, but 2 of them are alike. I've got a term in x squared. I've got 2 terms in xy here. Okay, and then I've got a term in y squared. Okay, so my final answer is going to be my single term in x, 3x squared. Now I'm going to have to combine these two together. I'm going to have to add them together. So what's 6xy plus xy? That is 7xy. And then I've got my 2y squared on the end, so plus 2y squared. Okay? So 3x squared plus 7xy plus 2y squared. I do recommend doing it in a grid. You know, it doesn't take much longer, and you're nearly always more likely to get all the terms right. Okay, so it just makes sense. Question 18. Triangle T is drawn on a coordinate grid, and we've got a series of transformations we need to do to it. Firstly, I've got a translation. Question A says triangle A is translated by 6 minus 3 to give triangle T. Draw and label triangle A on the grid. Now, there's a bit of a twist to this one because it says A is translated to T. So we have to kind of work backwards to work out where A was, so that when we translate it by 6 minus 3, we get to T. So we're going to have to go backwards on this one. So rather than, 6 minus 3 would normally be 6 to the right and 3 down. But we're going to have to go 6 to the left and 3 up here to find where A was, so that when it's translated, it lands on T. So taking one of the corners of my shape here, the bottom left corner, and I'm going to go 1, 2, 3, 4. I'm going to go 1, 2, 3, 4, 5, 6 to the left, and 1, 2, 3 up. So it's going to end up being here. Okay, let's just get rid of our wanderings. And then so I could do the same for the other 2 points, and that's going to give me those 2 points there then. So A would have been up here, so that once I translated it using that vector, then it's going to end down at T. So again, now if I just take the top of my triangle here and go 1, 2, 3, 4, 5, 6 along and minus 3 up, you can see it now takes me down to T, doesn't it? So this was A, so that when I translate it using vector 6 minus 3, I get my triangle T back again. Okay? Right, so that's A done. That was quite a tricky one, that one. Triangle T is rotated through 60 degrees anti-clockwise about 0, 0. to give triangle B. Now when you see rotations like this, just put your hand up in the air, ask for some tracing paper, because it makes life a whole lot easier. Okay, so what you then need to do is put your tracing paper out over your graph, trace your triangle, and also I recommend doing a little cross at the center of rotation. We're rotating around the origin here. Then stick your pen on the center of rotation, and then you can rotate it in whichever direction it says. Here it says anti-clockwise, until your cross lines up again and you know you've gone 90 degrees. Okay, and then kind of just keeping the tracing paper where it is, but kind of just pulling it aside to draw the points on. You should be able to work out that the points go here, here, and here. Okay, so that's going to be my triangle B. So let's just join the sides up. Call that triangle B. Right, and then finally, triangle T is reflected in the line y is equal to -1 to give triangle C. Right, where is the line y is equal to -1? Well, y is equal to are horizontal lines, and they pass through the number that you have. So y equals -1 is a horizontal line passing through y is equal to -1. Okay, so that's my mirror line there. Okay, so that's my mirror line, y is equal to -1. Okay, so then what I'm going to do is I'm going to take each point of my triangle T. I'm going to measure how far away it is from the mirror line. That's 1, 2, and then I'm going to draw my point 1, 2 points further along on the opposite side. Okay, so if I do that to each of the corners, I'm going to get a triangle that looks like that. Okay, joining those up, I'm going to get my last triangle, which is triangle C then, isn't it? Okay, calculate the square root of 5.2 squared minus 4.8 times -6.3. Okay, so I'm just going to carefully type that into the calculator. I'm going to put the square root sign, make sure everything it goes underneath the square root, the line goes all the way across when you're doing this. So 5.2 squared minus, well, I've got two minus signs, so those, I'm just going to change that in my head. I'm going to minus is a plus, so I'm going to do 5.2 squared plus 4.8 times 6.3. Okay, and then that comes out to be 7.568 and change. So I'm going to round off to three significant figures. So the 7.568 is going to round up to 7.57. Now this is a 2-mark question, so probably if you just want to play it safe, you're not sure about rounding, just write the whole number down first. That would be enough to secure you the first mark, whatever your display is on your calculator, and then if you round it off incorrectly, you're still going to get one of the 2 marks. Okay, so yeah, just a bit of a top tip to bank a mark along the way. The price of petrol decreases from £1.32p per litre to £1.2p per litre. Calculate the percentage decrease in the price. Okay, now I like to do percentages with this little triangle, final, original, multiplier. So I try and identify which is which from the question. So what is the final price here? It's going to go from £1.32 to £1.2, so that's the final price, 1.02. The original price is that one there. Okay, so that's going to go here. Original is 1.32, and the multiplier, that's what we're trying to find, isn't it? I'm trying to find the percentage decrease, so the multiplier is the thing essentially that I want to find. Okay, so that's the one I want. So covering that thing that you want to find, it tells you what to do with the other two. Just works the same way as a DST triangle if you've used one of those. So multiplier is equal to the final divided by the original. In this case, the final is 1.02 and the original is 1.32. So tapping that into the calculator, 1.02 divided by 1.32. That gives me 0.7727. I'm going to round it off to 0.773. Okay, now that's a decimal. If I want it as a percentage, I'm going to have to times it through by 100. That's 77.3%. Okay, and then we need to interpret this as a percentage decrease. Okay, now if you started off with 100% and you've now got 77.3%, then that is a decrease what would you have to take away from 100 to get 77.3? You'd have to take away 22.7%. So that's my final answer, 22.7%. Question 21. Trams to the airport leave every 50 minutes. Trams to the beach leave every 35 minutes. A tram to the airport and a tram to the beach leave together at 9:30 a.m. When is the next time that these two trams leave together? Okay, so what do we need to do here? Now, this is actually a problem on LCMs, lowest common multiples. Okay, so we want to find the lowest common multiple of these two numbers. Okay, now 50 and 35. Now you can just list out all the multiples. That's one way of doing it. So you could do 50, 100, 150 and so on until you find, and then you do the same thing with 35, 35, 70, 105 and so on. And you keep going until you find one the same in both lists. Or you can do prime factor decomposition, which is what I'm going to do here. Okay, so I've got 50 and 35. So I'm going to type that into the calculator, press equals, and then use the format key to rewrite that as prime factors. Okay, so you should see that 50 is equal to 2 times 5 squared, and 35 is 5 times 7. Okay, so then the LCM of our two numbers, the lowest common multiple, is every base that appears. So I've got a 2 in my number there, so it's going to have a 2 in the LCM. I've got a 5 and a 5 in my numbers here, but the biggest power of 5 is 2, so I'm going to have 5 squared in my LCM. And I've got a 7 in one of them, so I'm going to have a 7 in my LCM. So it's every base that appears, so 2 appears, 5 appears, 7 appears, to the highest power that appears in either expression. So like I say, I had a 5 and a 5 squared, so the biggest one is 5 squared, so that is what I include. Okay, so what is 2 times 5 squared times 7? Well, type that into the calculator. 2 times 5 squared times 7, that comes out to be 350. Now, I could, like I say, I could have just listed out 50, 100, 150, 200, all the way up to 350 and done the same thing with 35. Just to take it a bit longer, I think, because I know this method, I find it easier to find LCMs. So, but either way, once you've found your LCM of 350, we then need to take this and turn it into time. Okay, so this is 350 minutes. So what's that in hours and minutes? Now the easiest way to turn that into hours and minutes, so that's in mins. I want hours and mins, so I'm gonna divide it by 60. So 350 divided by 60. Now you notice I get a decimal. It's like 5.833, or you might have a fraction there on your calculator. Now I want to change the format of this number, and on the newest Casio, all you have to do there is go down to sexagesimal mode. So you go to the format key and then you go down to sexagesimal. Just a top tip, you can press up rather than down, and you get there in one go. And you should find it turns into 5 hours and 50 minutes. Okay. Now if you've got the older calculator, then you have to press the time key. It's the circle, dash and double dash button. Okay. Anyway, so that's 5 hours and 50. Now we know that the tram leaves at 9:30. So what I'm going to do is I'm going to add on 9 hours and 30 minutes to my current answer. So I'm going to press plus, and then I'm going to add on 9. And I'm going to press the time key, and 30, and I'm going to press the time key. So I'm adding on 9 hours and 30 minutes onto 5 hours and 50 minutes, and then I'm just going to let the calculator work it out for me. So again, I want that answer in sexagesimal mode, so I'm going to put that into the correct format, and you can see that I'm getting 1520. So add on 9 hours and 30 minutes, I get 15 hours and 20 minutes. Okay, so what is that as a time? This is in the AM clock, so they want it AM PM, I suppose. I'm going to put it in the same format. So 15 hours 20 minutes, that's 3:20 PM then as a time. Okay, So 3:20 p.m. So yeah, that time key is super handy for doing these sorts of questions rather than worrying about adding on and rounding up over 60 and all that biz. Yeah, just use the time key, it's super handy. Question 22. Hero and Taylor are both electricians. Hero does not charge to visit a house, but charges a fixed rate per hour for the work needed. This graph shows the relationship for the hours worked and the total charge made by Hero. Part A says, explain how this graph shows that Hero's total charge is directly proportional to the hours worked. Okay, well it is directly proportional because it passes through the origin and it's a straight line. So they're the two reasons why it is directly proportional. So it is a straight line passing through the origin. Okay, so for direct proportionality it needs to be both a straight line to show it's linear and it has to pass through the origin. Okay, if it doesn't pass through the origin and it's a straight line, not directly proportional. Right, Taylor does charge to visit a house and charges the same fixed rate per hour as Hero for the work needed. On the graph above, draw a graph to show the relationship between the hours worked and the total charge made by Taylor. So Taylor charges the same fixed rate, and that means that the gradient of Taylor's graph is going to be the same. Okay, so it's going to go up at the same angle as Hero's, but his is going to have a fixed charge, so it's going to be a little bit up from here. It's not going to pass through the origin. It's going to go in the same direction but not starting at the origin, but a bit above like that. Okay, so the same gradient shows that he's charging the same hourly rate, but then this gap here from here to here is the fixed charge. Okay, now if I knew what the fixed charge was, then I could say what that point is on the y-axis. So let's say he charged £25 call out, then that would be 25, wouldn't it, whatever it is. Okay, but I don't know what it is, so it's just going to be a bit above the axis. Eve, Jack and Ling share some money in the ratio of 2 to 3 to 4. Jack gets £720. Work out how much Ling gets. Okay, so we've got Eve, Jack and Ling in the ratio of 2 to 3 to 4, and we know that Jack, which is the middle column, gets 720. We want to know what Ling gets. Okay, so if you have a think about what you need to multiply 3 by to get 720, that's just 720 divided by 3, which is 240. I'd have to multiply that by 240 to change 3 into 720. Now if I do that to Jack, I have to do that to Ling and Eve as well. So 4 times 240 is 960, and just for completion, this one is going to be 480, although I don't really need it because I just need to work out how much Ling gets, and how much Ling gets is that one there, isn't it? She's going to get 960, or he's going to get 960. Not sure if it's a boy name or a girl name. 960. Part B, Amir, Beth and Casey share some money in the ratio 3 to 5 to C. Casey's share is 2/3 of the total. Find the value of C. If you have a look at Amir and Beth's share, we've got Amir to Beth to Casey in the ratio 3 to 5 to C. Then if we know that Casey's share is 2/3 of the total, then those two parts then are going to have to be the remainder. It's going to be 1/3. Okay, so Amir and Beth have got 3 shares and 5 shares each. So 3 plus 5 is equal to 8 shares. And 8 shares is going to be worth 1/3 then, isn't it, of the entire amount. Okay, so then if you times that by 3, then 24 shares is the total. And so C is going to be 24 times 2/3. It's going to be 2/3 of that, isn't it? Or it's going to be twice 8 shares, I guess. It's going to be 16. Okay, anyway, C is 16. Question 24, the probability that Sam works from home on Monday is 0.4. The probability that Sam works home on Friday is 0.2. Complete the tree diagram. Okay, now every branch needs to add up to 1. So if the probability on Monday he works from home is 0.4, then the probability he doesn't work from home on Monday is going to be the rest. It's going to be 0.6, so that 0.4 and 0.6 add up to 1. Now we're told in the question that on Friday his probability of working from home is 0.2. So that's going to be 0.2 on that branch. So that means the probability he doesn't work from home is going to be 0.8, and it's going to be the same down here as well. I'm going to get 0.2 and 0.8 at the bottom here as well. Okay, because it's independent. Doesn't matter if he worked or didn't work on Monday at home. It's independent on whether or not he works on Friday. So I've completed the diagram. Work out the probability that Sam works from home on Monday but does not work at home on Friday. So we want works at home on Monday but doesn't work at home on Friday. So what we want is the probability of home, not home. Okay. Now the probability that he works from home on Monday is 0.4, and the probability he doesn't work from home on Friday is 0.8. So then all we need to do then is multiply those two together to find his probability of that then. So 0.4 times 0.8, that is 0.32. 0.32, and that is my answer, 0.32. A 6-sided numbered spinner is thrown 50 times, and the score for each throw is recorded. Some of the results are shown in the table. An 8 was thrown F times. An unknown number on the spinner is represented by N. Okay, the mean score of 50 throws was 5.5. Find the value of F and the value of N. Okay. Well, the value of F is fairly straightforward because we've got a total at the bottom there, haven't we? We've got a total of 50. So presumably then all of these numbers down here are going to have to add up to 50. So if I take what they do add up to away from 50, I'll be left with F. Okay. So given that 12 plus 2 plus 9 plus 16 plus F plus 4 is equal to 50, then those numbers added up, 12 plus 2 plus 9 plus 16 plus 4, that adds up to 43. So F plus 43 is equal to 50, and therefore F is going to be 7, isn't it? So that's 7 in there. Okay, so I know that's 7. Now I know how many of each they've got. I can go on and find an estimated mean, I guess. Well, not an estimated mean, the actual mean, because they're all the precise scores. So to find the mean, I need to multiply all these together, add them up, and divide by 50. So I need to multiply these all together, add them up, and divide by the total of the frequencies, which is 50. So 1 times 12 is 12, 3 2s are 6, 5 9s are 45, 6 16ths, what's that, 80, 96, 8 Fs, oh we know that F is 7 now, so that's going to be 56, and I've got 4n, and I know that adds up to, well I don't know what that adds up to, I know, well I do, I know what the mean score is, so we can use that in a sec. So anyway, let's just add that up then. So I've got 12, 6, 45, 96, 56, what's that add up to? So 12 plus 6 plus 45 plus 96 plus 56. That comes to 215. So I've got 215 plus 4n as the total. Okay. Now to find a mean, the mean is going to be the sum of the f times x values divided by the sum of the f values. So the sum of the x values that we found, that's this sum here, isn't it? So the 215 plus 4n. 215 plus 4n. The sum of the frequencies, that was 50, wasn't it? So I'm going to put 50 in there. And we know the mean. Mean was given. Mean was given as 5.5. So that goes there then, doesn't it? So 5.5. Okay, so we've got an equation in n here that we can rearrange and solve for n. So multiplying both sides through by 50, 5.5 times 50, that comes to 275. So 275 equals 215 plus 4n. Taking 215 away from both sides. So we times that by 50. Now we're subtracting 275. No, we're not. Now we're subtracting 215 from both sides. That leaves me with 60 on the left, doesn't it? 275 minus 215 is 60, so that must be 4n. So then dividing through by 4, what's that? 4's into 60 go 15 times, so n is going to be equal to 15. Okay, so we've got f is 7, and we've got n is 15. Here is a table of values for y equals 6 over x minus 2x. Okay, so they've already found all the values for us. That's nice of them, isn't it? So we just need to plot these points. So minus 4 goes with 6.5. Minus 4 goes with 6.5, which is there. Minus 3 goes with 4. There. Minus 2 goes with 1. Minus 1 goes with minus 4. 1 goes with 4. 2 goes with minus 1. 3 goes with minus 4. And 4 goes with minus 6.5. So there. Okay, a very strange looking graph. Okay, now notice that it's not defined at 0. That usually means that that's a undefined point. It's like an asymptote, so this is where the graph kind of shoots off to infinity. Okay, so this is going to be a discontinuous graph, so there's going to be a break in it at the y is equal to 0. Okay, so the graph shape should come down through each of these points. Now when you're drawing these, it's important to actually go through each of the points. We're heading off down to minus infinity down that way. We're going to go around the universe and kind of come back down from positive infinity back through our points here. Okay, it's a little bit like the reciprocal curve, but not quite, because you've got that minus 2x on the end. Okay, which gives it a bit more of a weird shape. Okay, so that's my graph. Curious. So yeah, that's a very strange looking graph. So use your graph to find the positive solution of 6 minus x minus 2x equal to 0. Well, y equals 0 is the x axis. So if you've got an equation set to 0, then you're looking at where it crosses the x-axis. Okay. Now we want the positive solution. Now noting that there is a negative solution here, isn't there? That's a negative solution because you've got a negative value of x, which is there, and then that's your positive solution there. So that one reads off to be about 1.7. So to one decimal place, and that's going to be 1.7. Okay. The diagram shows a circle inside of a square of side 12 centimeters. Work out the percentage of the square that is shaded. You must show your working. Okay. Right, so first off, if we want to write this as a percentage of the total area, we need to find out what the total area of the square is. So total area of square to start with, that's the easy bit. Well, a square is just length times length, isn't it? It's going to be 12 squared, it's going to be 144. So if we're working out the percentage, then that's going to be the number on the bottom, isn't it? Okay, now we need to work out the number on the top. That's the slightly harder bit. So what is that kind of weird shaded part there? Okay, well if you think about it, what you've got here is if I take my square and I divide it up into 4 quarters, like so, then what we've got is that in that shaded area is a quarter of the square subtract a quarter of the circle then, isn't it? And that's going to leave me with that shaded bit here. So if I take a quarter circle, if I take a quarter square and then I take off that quarter circle, I'm left with shady area. Okay, so quarter square, that's going to be, well, it's just going to be 144 over 4. Same thing as 6 squared, really, isn't it? So it's 36. Okay, and then we've got the quarter circle. That is going to be pi r squared over 4, where the radius is 6, isn't it? So that's going to be pi times 6 squared over 4. 36 over 4, that's 9, isn't it? So that's 9 pi. Okay, so then the shaded area is going to be the quarter square minus the quarter circle, which is 36 minus 9 pi. I'm just going to leave it as pi for now because I'm still going to do some more calculations with it. Right, so then, now I know the shaded area and I know the total area, so then I can work out the percentage shaded now. So percentage shaded, that's going to be shaded area over total area, which is going to be 36 minus 9 pi over 144. Yeah, so we found the total area of the square here was 144, and we found the shaded area to be that. So dividing one by the other, then we're going to get our answer, then, isn't it? Now this time I'm actually going to evaluate it. So I'm going to use the fraction key. I'm going to write the 36 minus 9 pi on the top of the fraction. And then 144 on the bottom. What does that give me? Apparently that's 0.0537 to 3 significant figures. What are we going for? I suppose to 1 decimal place. So I'm going to go for 0.054 then, I guess. That would be, when I convert that into percentage, that would be to 1 dp. So 0.054, which is 5.4% then. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.